So last worksheet, I was overjoyed because we had a chance to utilize some of the parallel angle relationships that we went over in Unit 2. And then we took a break with transformations. And after we did the transformations, it's like, well, what's the next step? Now we're getting back into triangles again. This particular lesson takes advantage of the relationships between parallel lines and triangles again. And so in this case, oops, messing with the, sorry about that. I got the wireless mic messing with Windows. So in this case, the triangle proportionality theorem tells us that, yeah, mics are still on, tells us that if a line is parallel to one side of the triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. So how do we know that they are proportional? The way that we know that they are proportional is because if you have two parallel lines that bisect into a triangle, if they are parallel, then they will generate similar triangles, and they will generate similar smaller triangles. And if they are similar smaller triangles, that means that they are going to be immediately similar to the bigger triangle. Now, how do I know that they're going to be similar? How do I know that they're going to be the same size? Because if they're similar, that means that all the sides are going to be proportional as well. Well, let's take a look here. I've got this triangle here, and that's being bisected by a parallel line. So what I'm going to do is I'm going to draw these lines out. And so we've got our triangle here, and we've got our, oh, there we go. We've got our triangle here, and we've got our parallel lines. Well, if I've got this angle here, this angle measurement here, and I've got another parallel line that's cutting across this, if these two are parallel lines and this is a similar transversal and this is the same transversal, if you remember what corresponding angles are, if you have two parallel lines that are both intersect the same traversal, then these two are going to be corresponding angles. So these two are going to be the same angle because these two lines are parallel, because these are going to be corresponding angles. By the same token, these two are going to be the same measurement because they are also corresponding angles on the same traversal intersecting two parallel lines. Now, what does this mean? This means that angle D, angle B, and angle E are all going to be the same, are all going to be, wait a second, 2, 3, there we go. So angle D is going to be angle measurement number 1, angle E is going to be angle measurement number 2, and B is going to be angle measurement number 3. All right, well, let's take a look at the bigger triangle. Angle A is going to be angle measurement 1, angle C is going to be angle measurement 2, and then angle B is going to be angle measurement 3. These two triangles are similar, and so because they are similar, all of their sides are going to be proportional. And so BE is going to be proportional to BC. BD is going to be proportional to BA. And then, of course, the big one, DE, is going to be proportional to AC. And the reason I know that is because they are similar triangles that have all the same angle measurements, just different length sides. And if they have all the same angle measurements, but different side lengths, you know that those side lengths are going to be proportional to one another. It's just an issue of finding the scale factor. So let's take a look at some examples. So we're trying to find the value of x. I'm trying to find the value of x. I've got my parallel lines here. I've got my triangles here. So what this means is that this whole side is going to be proportional to this side, the same way that this side is going to be proportional to this whole side. So it sounds to me like I've got my scale factor set up pretty well. That means I've got 26 is to 12 as 15 plus x as 15 plus x is to x. So again, I've got 26, which is 14 plus 12, is the same as, oh, wait a minute, is the same as 14. There we go. Hmm. Let me get a set. Let me try this again. Something doesn't seem right. So I mean, I've got the idea right. I just want to make sure that I have the proportions exactly right before I move on and start doing some crazy math. So I'm solving for x. So that means that 15 plus x, that's right, is proportional to 15. The same way that 12 plus 20, 12 plus 14, so that's 26. Yeah, 26 is to 12. That's right. So the small side is proportional to the long side, the same way that the small side is proportional to the long side. Okay, all right. So now I've got everything set up correctly. That makes a little bit more sense. Okay, so 15 times 26. Oops, turned it off by accident. So 15 times 26. So that gives me 390 equals 12 times 15, 180 plus 12x. So 390 minus 180, that gives me 210 equals 12x. So 210 divided by 12, so 17.5 equals x. And there we go. So again, because I know that they're similar triangles, all I have to do is set up the proportions. I have to set up the ratios and the scale factors, and then I can solve for anything. And this proportionality theorem basically says that if we start incorporating parallel lines, like from Unit 2, then we can get a little bit more information. So let's give this one a try. So again, we're going to go. I'm just going to write this down, small to large. This is just to keep my thoughts organized. You don't need to do this yourself. Um, x is to x plus 18. Yeah, x plus 18 as 56 is to 56 plus 21 is 77. Yeah, that works out all right. So that gives me 77x equals 56x plus 18 plus 56 equals 74. So 77 minus 56 equals 21. So 21x equals 74. Let's see, 74 divided by 21 equals 3.52. X equals, see, that doesn't seem right. I'm pretty sure, yeah, that doesn't seem right. So this is the importance of setting up reality checks for yourself and making sure that you've got everything worked out. Because the final answer that I got is that x equals 3.52. That doesn't make any sense at all. Because if x equals 3.52, then what that means is that 3.52 is at least 3 or 4 times as big as 18. So it's that, and it's not. Um, so what we're doing is the proportional side. So x is to, so yeah, x is to 18 times x, as 56 is to, did I set that up correct? Yeah, 56 is to 77. Did I just multiply it through incorrectly? So yeah, we'll give this another try. We'll give this another. I think I've got space on the back, so I'll just write it out here. So yeah, this is bothersome, but we'll take a look at it. So I may not have set it up correctly. Anyway, so we're starting with the large one. Oh, that may have been what I did wrong. Okay, all right. So what I did was the small one is x, to the large one is 18 plus x. So small to large is x, and 18 plus x is the same as the small one. 56 is to 56 plus 21, which is 77. I think this is what I did different. Yeah, I think this is, yeah. So that gives me 77x equals 56 times 18. Okay, I think I'm on the right track now. 1008 plus 56x. Okay, 56x, so I'm going to subtract 56x from both sides, so 77 minus 56 equals 21. 21x equals 1008. So 1008 divided by 21 equals, there we go, x equals 48. That makes a whole lot more sense. There we go. That makes a lot more sense. I just had it set. It's one of those things I just rushed through it incorrectly, thinking that I knew what I was doing really fast. So yeah, and it all started because I wrote down I wanted small to large. All right, let's move on to another problem, and hopefully I can redeem myself. Let's see. So I'm going to go small to large again. So x is to x plus 36 as, let's see, if the whole thing is 45, then that means that the small part is 10 is to 55. So I got small is to large, x is to 36 plus x as small side, so this one is 10, is to 55. Alrighty, I think I've got this set up. So 56, so that means I'll write it over here, 55x. Yeah, I'm still on camera, awesome. So 55x equals 10x plus 360. Subtract 10x from both sides, that gives me 45x equals 360. X equals 360 divided by 45 on the calculator. 8. There we go. That makes a little bit more. Now we're on the right track. Now we're on the right track. All right, 27. So I've got 27/6. So that means this one's 21. So what I'm going to do is I'm just going to do another small to large. So I'm going to go with, well, yeah, smaller to larger one. It's not that much larger. The small triangle is smaller. It's not much smaller, but anyway. So x is to 7 plus x as 21 is to 27. All right. So 27x equals 21 times 7 equals 147 plus 21x. Yep. 21 times 7 is 147. 21x. Yep. Subtract 21x from both sides. That gives me 6x equals 147. Yeah, 21 and 7. Yep. I can divide 147 by 6. And then x equals 24.5. That makes sense. I'm usually a little bit more partial to whole numbers. That always makes me a little bit more comfortable when I'm doing some of these worksheets. But 24.5, that passes the smell test. That I look at that and I'm like, okay, yeah, I can see 24.5 with that one. Alrighty. So with this next one, oh, they're switching it up on us. So small to large. So that's going to give me 30 is to 30 plus 30 plus x plus 7 is the same as 25 is to 25 plus 15 is 40. Okay. Now notice what I did here. I did 30 is to x plus 7. Oh, there we go. There we go. Now you can see what I did. I didn't combine any terms yet. I'm not going to combine any terms. This was a habit I picked up while I was in algebra. Write it down exactly as it appears, and then worry about the terms after you have it written down as it appears. So let's see. I've got 30 times 40. So that gives me 1200. Do that over here. Equals 25 times 30. 750 plus 25x plus 7 times 25, 175. So what that means is 25x equals 1200 minus 750 minus 175 equals 275. Therefore, x equals 275 divided by 25 equals 11. Alrighty. So a lot of the issues with this unit, the concepts themselves are going to be relatively abstract, but it's going to lead directly into being able to do algebra-based math. So hopefully everyone's going to be happy with that. Yeah, moving forward. Again, I'm going to write myself a little note. So, all right. 3x plus 1 is to 3x plus 1 plus x minus 1 as 21 is to 27. Well, that's not really too exciting, but hey, I mean, we're working with it. So 27 times 3, so that's 81 plus 27 equals 21 times 3